you. So we are going to find the total number of elements in the sample by adding all of the frequencies together. So I'm gonna add these numbers together. So if I get 30, 46, and 6 is 42.
I think it was the other one.
The other one.
Yeah,
right.
the 13, 31, 26,
Okay.
15.
Let's add the other one as well. That's always fun to add numbers. So it looks like 3 and 1 is 4 and 6 is 10, and another 9, so it'll be 9 and carry 1, right? So it'll be 2 and 3, 5, and another 4 is 9. So it looks like 99 to me. Please correct me if I'm wrong. So you add all of the frequencies, and that's how you produced the total number of sample elements. I know the exercises here are a little bit different. They don't ask you to do that, but well, I just added the numbers for fun. So sample size is probably the most important thing to know in all the exercises in this chapter. And of course, it's good to realize that some of the frequencies must be equal to the total number of elements in the sample. So if you add all of them together, then you must get your sample size. And that's why we use name distribution. So let me flip the page and see what else they have here in this little section. And you can see there is more in here. So let me try one more exercise just to refresh all of the processes that we already considered. And looks like there are various samples in here. So how about if I take a look at like exercise number 17. There's a sample with a bunch of numbers. Actually, there are quite a few numbers here. So they say in the year 2017, they had following ages in chronological order in which United States presidents were inaugurated. Okay. So what do they want? They want a frequency distribution for this data, and they want to use 41 through 45 for the first class. Okay, sounds like an interesting plan. So first of all, I want to produce these classes and then produce frequency distributions. So I need to get so-called frequencies. So let's recall what that means. So they told me, Alex, use first class as 41 through 45. And then based on this observation, I probably should go 46 through 50 for the next class in order to have it be of the same exact length. So we also have here 41, 42, 43, 44, 45, 5 elements. And notice that in the next class, 46, 47, 8, 9, and 50, another 5 elements. So my classes should be same in length. So next class I'll run from 51 through 55. Then analogously to the second, it will be 56 through 60, then 61 through 65, then 66 through 70. So the question is, how far should I go? Well, I do see 70 here, so I definitely need 66 through 70 class. Do we have any greater numbers than 70? Looks like not. Okay, so we've got classes. Looks like they told us here to have like 6 classes. So then what? Well, then I'm gonna look for the number of class elements. or so-called frequencies. So right now, I'm looking at the first class that ranges from 41 through 45, and I see only two elements. I just cross them out, 42 and 43. Please double check if I did it right. And now I look for more 40s. So I have 1, 2, 3 in the first row, then 4, 5, 2 more in the second row, 5 total, and then 2 more, so it'll be 7, right, for the next.
But professor, it goes up to 50. You need to count the 50.
Oh yeah, you're right. See, I need to wake up. I need not to just count 50. I also need to wake up. Thank you. Alex, wake up. Okay, so let's add a 50 from the first row. Thank you. Thank you. So any more 50s here? Looks like just one, right?
At the beginning between 40, yeah, here on the second,
Second.
the-
Oh, I see. I
yeah.
see. In the see, it's hiding, but it cannot hide from you. So 9 then, right? Pair of 50s. Thank you so much. See, these problems are a little bit challenging. You need to be very concentrated. So how about next class? Up to 55. I say, Alex, are you gonna give us that on the exam? What if I don't keep my concentration for that long? I'm going to arrange numbers for you so you won't have to go through this pain. So no worries. If numbers be arranged, it'd be much, much easier. So anyways, let's do the next one. So it's 51 up to 55, right? So with 1, 2 in the first row, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 for the next class. No, 14, 54 is also here. Wow, that's a popular class, up to 55. Okay, so let me get the next one, up to 60. So let's see, 1, 2, 3, 4, 5. Oops, 54 is here. So I was supposed to put it in the previous class. So let me fix it real quick so nobody can see this. My mistake again. See, you just need to definitely be practicing more on this, but I know what this is for. It's, if sample be arranged, it wouldn't be a problem. So anyways, let's go back. 1, 2, 3, 4, 5. Any more? 6. So 6 from the first row. The second row, 7, 8, and then the third row, 9, right? 9. Okay, 9. It's getting less. It's getting a little bit nicer, a little bit. So up to 65 now. So what's left here? I'm gonna put this on the top. 61. So it's 1, 2, 3, 4, and then I missed. Oh no, it's here. 5, 62. 5, and then we have 6, 7, and that's it. 7. We'll double check. Don't worry. At the end, I'll show you how to double check. You probably already know how to double check. So 68 is left, that's 1. And then we see number 69 and 70, so it looks like 3 only left for the last class. So the way to double check is to add all of the frequencies and hopefully get your total sample size. So let me add them first and then see what we're gonna get. 11 and 9 is 20, and then a 10 is 30, 45. So there are 45 elements of data. Let's see. 2, 4, 6, 8, 10, 2, 4, 6, 8. So 18 twice is going to be 36. 7, 8, 9, 40. 1, 2, 3, 4, 5. Yes. Ooh, that was a very serious moment in my life, because if I messed up, I would have to redo the whole thing again. And that's not much fun, but it feels good. I don't have to redo it with your help. So thanks for your help. So I've done the frequency distribution. That's all they wanted. And that's what I did. Of course, it's shameful to feel that you could produce this nice wiggly thing that we have on the diagram. So let me produce that one as well. So I'm gonna get myself the so-called histogram. Remember how we did that? We need to get the smallest and the largest elements of our classes now. So we run from 41 through 70, and we used to have 6 classes. I need to cut it in half, and then each of this in 2 pieces, and those in 2 pieces. And then I'll put starting points of my class, such as a next class starts at 46. See, I put starting points only because there is no room to put end starting and end. So next is 51, then 56, right? And so forth. So it'll be 61, and then 66. When you say Alex, so it'll be 71. Well, it ends at 70, so that's fine, I guess. Well, now, I don't want to go all the way to 0 because there is nothing on the left. So people put this little wiggle to say, okay, so we kind of squeeze this line. You see, they also put this wiggle here on the graph. And that's so that means we don't really want to go all the way to 0 because we only care starting at 7. And then highest point will correspond to my largest frequency of 15. And then based on this, I will be placing all the others. Like, for example, the first class is of the height 2. So that's a pretty low little bar of the height 2. Then I get 9. Well, 9 is definitely more than a half, some approximately here. So that'd be my second little bar here. Then we go with a 15. Oh, that's the tallest. That's where it is. So the tallest is 15 here. Next is 9. So you get that one like that. Then we have 7. 7 is less than 9, somewhere here. So I'm doing my best to keep this as proportional as possible. So 2, 9, 15, another 9, and then 7. What is going on? I think I didn't put it correctly because my 41 is actually here, but I have started there. So see, today I'm not concentrated. It's Friday is kind of messing it up. So let me put it more carefully because I was supposed to actually start this at 41. I started there. I don't know why, I just messed up. So, well, it's not hard to fix. And you will notice that. Maybe it's good that I messed up, so you will see that you will eventually notice that you have more classes than the bars, and that wouldn't be good. So I just moved everything by 1 class to the right. And my final one will be 3, so it's right here. So this is a histogram that I produced. If you want that frequency polygon, okay, fine, just get the middle points of these bars connected with straight line segments. So like that, and like that, here, and then sit it on the axis. So sit it in the start and at the end of your symbol. When you say, Alex, why are you doing this? The problem didn't ask you for that. Well, I'm enjoying it. I guess that's the answer. You want to start enjoying it, and then you're really going to like statistics. And that's the key part to really enjoy what you're doing, right? So just like my neighbor, he really enjoys singing. He sings someplace, well, I'm not even sure where. I don't want to go there because I hear his singing pretty much all day long after 6 p.m. when he wakes up. So he just sings, and I was talking to him. He says, Alex, I love singing. I cannot live without singing. Whether I get paid for it or not, I just keep on singing all the time. So you should enjoy it. That's very interesting. That's how you want to approach this, because if you say to yourself, I hate this singing, I don't love to sing, you will never like whatever you're doing. But you just want to make yourself believe that you love singing, just like my neighbor did, because I would say he really sucks when he sings. Oh, no good. But he loves it, doesn't think. Maybe he's lying that he's working somewhere because as a singer. Maybe he's working as a bartender, but not as a singer. That's for sure. So, anyways, enjoy and everything be fine. That's the message. So, what else is in this section? We did not consider the stem and leaf display, or so-called stem plot. So what I'm talking about is the picture that section also provides. Let me show you where to find it. So I think last time we looked at it, it's just somewhere on the bottom of the page. And that's what I intend to produce right now for the actual stem plot in this exercise. Here it is. So stem and leaf plot for 40 scores. So what I'm going to do with this exercise is analogous procedure. So notice that my sample elements, they range from 40 through 70. So I'm going to put their first digits, 40, 50, 60, 70 for the little stem, like that. And the second digit I will put in the leaf. So now I'm going to go to the page where we have that sample. So let me do that. Where's this exercise? So again, I'm making this up, but it's, I think, another nice display of the data that we can utilize when we describe it. And now I'm going to be selecting second digits for all numbers that have first digit 4, such as a 49. So I'm going to put second digit 9 here. So what else? 48 and then 46 in the first row. Okay, I put 8 and a 6. The next, I get another 49, 47, 42. Okay, so 9, 7, the 2. And then looks like 46 and 47, another pair. Okay, 6 and 7. And that's great. So I put these underlined numbers such a way that first digit 40 is producing so-called stem, and a leaf is going to be all of these second digits. Now, I start with 50s. It looks like I got a 3 57s, actually 4 of them on 58. So I put 7, 7, 7, 8, and there was another 7. Please notice the way I put them is I align. So I put them exactly underneath my digits above. So this way I will be able to compare and see which class has more elements. So if I continue 54, 51, and then 50, so it'll be 4, 1, and then 0. Then I start to see that we have more in the second class because there's more, 52, 56, that's my first row, and there'll be some more coming in from the second, right? It's 54, 50, 2 55s, so put 4 50, so it'll be like a 0 and a pair of 5s, right? Oh, I'm running out of room. So let's see what else is. 4, 1, 6, 5, 1. So let me maybe try to scroll this up. So 4, 1, 6, 5, 1. Oh, would I be able to somehow fit this? See, I wasn't ready to have so many of these guys. Maybe I'll get like that. I still need to see this. Not sure if that's going to help. In the middle. Okay. Okay, so I ended with 1. Then there is also 55 in that same row, so I put a 5. Looks like that'd be probably the most popular row, right? And then 6, 2, so I put 56 and then a 2. And what else? 54, and that's it. Okay, enough already. 54. So now I go for 60s. How many of them are here? 61, 61, 68. So I put pair of ones. Again, I align them so we can see which class is going to be bigger. And then 64, and then 5, and then that's it in the first row. So put just 4 and 5. Okay. So next we have 60, 62, just 2 more from the second row. Okay. 0 and 2. So which class will be bigger, 40s or 60s? Let's see. 61, 69, 64. 1, 9, 4. Give me larger class number 3. Okay, so how about 70s? Do you see anything else besides the very, very last one? I don't. So looks like we have finished with a stem plot. So please notice in some cases, stem plot may be a little bit better display than the histogram. Well, it still gives you a depiction that the most popular here in between 51 and 56. And here we see that 50s is actually the most popular one. But, well, once you displayed your data, it's always much better rather than just give people this bunch of numbers. So nobody will understand anything this way. But with your histograms or stem plot, it's much more intuitive. And it's definitely very useful for samples that have hundreds of elements. If you have 1,000 element sample, if you give someone a book with numbers and say, oh, that's my sample elements, well, they will just don't feel like talking to you ever again, because with this bunch of numbers, people will be extremely confused and wouldn't understand anything that you're trying to tell them. So anyways, that's all I wanted to say about this section, and we're gonna move on to the next section. The next section will continue working with samples, and what it does, it talks about the central tendency, such as the average or sample mean. I think that's a very interesting word, mean, because you do encounter it. Let me clean all that. Mean, that's nothing else but average, right? Sample average. And the way you find it is you add all of the sample elements together. So this special symbol, which is called sigma, that's what we use for sum. Not sure if you ever saw this before. Well, but now you just saw it. So that's a sum of elements of the sample. So for example, if I have $1 and you have $3, then what we have in average will be $2, because we add 1, 3, which is 4 divided by 2. So that will be $2. And if there be 3 people and I still have $1 and you still have $3, and someone you know has a million, well, then you can find the average by adding these three numbers together and dividing by 3. And that's probably what I need my calculator for, right? So you will say 1 plus 3 plus that million. And I want to put parentheses to make sure this is going to be divided by 3. So we average this. And every one of us will have 333,000 something dollars. Well, probably your millionaire friend is not going to like this idea to average her money with some other people, but that's what the average is about. So you add everything in the same pile and then share it all equal, right? So looks like the idea of average, but in this section, they call it as a sample mean. So instead of saying average, you can say, Alex, why wouldn't you just say average? Why do you use that word mean? Well, we're in statistics, so statistics is very famous for creating its own words. But, well, if you call it as average, I will understand, so no worries. So let me go back to the textbook and maybe calculate a sample mean for you myself. Looks like they already doing it here. You can see this exercise and they add all of the sample elements together. So why don't I just take one of these exercises and calculate sample mean? And maybe then I'll let you go because the story will continue and we need to actually spend some time to get used to this ways to calculate various sample means. So let me try to show you how to do this using your calculator. So for example, if we look at the exercise here, like problem number, let me take 8. Let's take something nasty. Exercise number 8. Look at these numbers. They don't look very attractive, right? Definitely not. So what you want to do, you want to take this 1.4, add it with a 2.1, add it with 1.6, add it with 3, add it with another 1.4, add it with 2.2, right? And more of these guys. Looks like it's another 1.4, 9, 9, and 1.8. So plus another 1.4. What I can do is maybe scroll this a little bit so I get a little bit of room to fit in it. Up here. So pair of 9s and 1.8. So this way I can fit this. Oh, that's good. 9 and 1.8. And then I'm gonna have to divide this, the average, all that, over the number of entries I have here. 2, 4, 6, 8, 10. Okay. So divide the sum by 10, and that's how I produce the sample mean. That's what they want me to do. And I definitely want to use my calculator for this. I know some people are just phenomenal. They do this in their mind, but if you make a mistake, that's no good. You want to do it right. That's the key idea. You want to take your time. I never tell you do it faster. No, I give you plenty of time. You probably noticed that. So you want to make sure that you don't hurry and just do it right. So how to do it right? Well, use a calculator. And I recommend you to use this free online so-called Desmos calculator that I found there in the Google search. So it's a nice calculator because look at this. It shows you how you enter this whole thing and divide it by 10. And it gives you the answer 3.29. So you could just see the whole thing entered at once. So I will be using this calculator for in-class demonstrations. Let me show you how to find it. So just go in the search engine and start typing scientific calculator. Look at this. Once I type scientific calculator, well, this one is no good. That one that Google provides is no good. Use Desmos. It's a free calculator, so you don't have to enter your email anywhere or anything. You just click on it and use it for free. So I think that's a great deal, right? So here's the calculator. I will be using it. And I guess once you saw it, you deserve to relax and start enjoying your weekend. How about that? After this whole week of everything, you definitely need a break, right? So no quiz for you today, and we'll continue with this story on Monday. So you don't need to worry about 12.2. I just finished up with a section 12.1 today, and we'll continue with more of 12.2 on Monday. So just have a good break. And again, we'll meet on Monday. Again, no quiz. Thank you. Thank you so much. Thank you for
Bye,
being.
Professor. Thank you.
Bye-bye. Have a great day.
Have a great weekend, Professor.
Thank you. Thank you. Bye-bye. Thank you. Enjoy your weekend. Bye-bye. Bye-bye. Have a good day. Thank you for coming. Bye-bye. Okay, so if there are no questions, I'm gonna end this class and we'll continue on Monday. How about that?